Hello and welcome to our first video in the Java interview preparation series. Today we'll discuss object-oriented programming or OOP. This is a fundamental concept that every Java developer must understand to build scalable, maintainable, and efficient software solutions. What is OOP? So, what exactly is OOP? At its core, OOP is a programming paradigm that models software using objects. An object represents a real-world entity combining data and behavior. For example, a car can be an object. It has attributes such as its color and model, and behaviors such as starting engine and stopping engine. This approach makes it easier to write modular and reusable code, which is critical for complex systems. Why is OOP important? Why should Java developers care about OOP? First, OOP simplifies complex systems by breaking them into smaller, manageable objects. Second, it promotes code reuse through inheritance, saving time and effort when writing new programs. Additionally, OOP makes debugging and testing more straightforward, because you can isolate issues within specific objects or classes. For Java, these benefits are essential as the language is designed with OOP at its core. Key principles of OOP. Now, let's talk about the 4 key principles of OOP. These principles are the foundation of how object-oriented programming works in Java. Abstraction focuses on hiding unnecessary implementation details and exposing only the important functionality, like an API. Encapsulation protects data by bundling it with methods that control access, ensuring security and reliability. Inheritance allows one class to inherit properties and methods from another, promoting code reuse. Finally, polymorphism enables one interface to represent multiple implementations, making your code flexible and dynamic. We'll explore these principles in more depth in upcoming videos. Java and OOP. Java is one of the most popular object-oriented programming languages. It revolves around the concept of objects and classes. Everything in Java, except for primitive types, is treated as an object. Let's take a look at a simple example. Here, I have created a car class. It has 2 attributes, color and model, which are defined as private to follow encapsulation principles. This means they can't be accessed directly outside the class. Next, we have a constructor. This is a special method that allows us to create a new car object by specifying its color and model. And finally, we have added 2 methods, start and stop. These represent the behaviors of a car, and when we will call print sample messages to the console. This illustrates how Java uses OOP to structure real-world entities into code. Now let's look at an example of how we can create and use an object in Java. In this code we have a main class with a main method. Here we create an instance of the car class, specifically a red Tesla car. Once the car object is created, we can call methods like star and stop. These methods represent actions the car can perform. When the start method is called, the car would output car is starting, and the stop method would output car is stopping. Even though we are not running this code right now, this example shows how Java uses objects and methods to represent real-world entities and their behavior. This approach helps us write code that is modular, easy to understand and reusable, which is a core principle of object-oriented programming. By designing our code this way, we make it easier to manage complex applications and extend functionality as needed. That's it for our introduction to object-oriented programming. In the next video, we will dive deeper into the two foundational concepts of OOP: objects and classes. Stay tuned and happy coding!